Have you ever wondered how the process of arc welding works and how it is simulated? Arc welding, in essence, is a process that uses electricity to melt and fuse metals together. This fascinating process comes to life when the air or medium around a high-voltage electrode and base metal is ionized. This creates an electric arc that generates the heat necessary for welding. Quite intriguing, isn't it? Now, imagine this process in a simulation. The electrode is positioned 4 mm from the base metal. A voltage of 400 volts is applied, and the base metal is grounded. Air enters the scene at a speed of 1/100th of a meter per second and a temperature of 1000 degrees Kelvin. Meanwhile, the cathode wall is at a balmy 2000 degrees Kelvin. The electrical diffusion coefficient of the ionized air is a mere 5/1000ths. The geometry for all this is created in SpaceClaim and meshed in ANSYS Meshing with 335,560 structured elements. Given the low velocity and small length scale, the simulation treats the problem as laminar, thereby activating the energy equation. A user-defined scalar, or UDS, simulates the electrical potential, and the current flow density is calculated using a specific formula. The energy equation includes a source term for electrical heat generation. A user-defined function, or UDF, implements the formulation, and user-defined memory, or UDM, tracks the electrical heat release and current vector for post-processing analysis. Output. So, what do the results tell us? They show velocity and pressure contours around the cathode, and a base metal surface temperature reaching 1220 degrees Kelvin, which is sufficient for melting. The maximum temperature in the domain is 7036 degrees Kelvin. The highest heat generation is near the cathode due to the greatest electrical potential gradient, and current vectors show the flow from the cathode to areas of lower electric potential. In summary, arc welding is a complex process that uses electricity to melt and fuse metals. It involves ionizing the air or medium around a high-voltage electrode and base metal, creating an electric arc that generates heat for the welding process. The simulation of this process involves a multitude of elements and parameters, but it ultimately provides a detailed and insightful look into the intricacies of arc welding. This understanding can help refine the process, making it more efficient and effective. So the next time you see a welded structure, remember the fascinating process behind it and how a careful simulation can help perfect the art of arc welding.